let's get started. So what's the cross data center application is, right? So cross data center application in simple terms means it's having the same data across multiple clusters and keeping them synchronized. The way we achieve that is by setting up a replication streams between the clusters, so that any data changes or if any mutation or any changes to the data will get replicated from the source cluster to the destination cluster, right? So what are the use cases of the cross data center application, right? So there are some of the main use cases we have is the disaster recovery or the workload distribution, and also the data locality, which is bringing data closer to your user, right? So we'll talk more about this use cases in detail in the presentation. So let's now talk about what are the basics of cross data center replication in Couchbase Server. So in Couchbase Server, the cross data center application is the replication of data between the Couchbase clusters, right? And this Couchbase cluster can be geolocated geographically on a different location, right? They can be located anywhere. They can be on the same continent or it can be on the different continents. So this Couchbase cluster can be basically located anywhere. We can set up the replication streams going on between the clusters. Right. So one of the other things which we support in Couchbase is by setting up the replication on a per bucket basis. That is, on a bucket is identical to a database in relational world. So that gives you a granular control. In the sense, you can pick and choose which database you want to replicate and which database you don't want to replicate. So depending upon your application needs, right? So some of the most common use cases, some of the most common configuration we support is like unidirectional application and the bidirectional application. With this configuration, we can support master-slave, master-master, or master-master-master, which is multiple master configuration, right? So when we have this active-active, which is master-master configuration, your application server can do read and write on both the clusters, right? So you can do the read and write operation on both the clusters. And most common question we get is, how do we handle the write collisions, or how do we handle the conflict? And we have a slide which is going to talk about that in detail. And we have some mechanism to do the conflict resolution, right? So one another basic thing about the cross data center application is the replication throughput scales out linearly. What that means is if you have more nodes in your cluster, then your workload is evenly distributed, and depending upon more nodes, you can have more streams for the replication, and your replication rate will be much faster. So your throughput will be much faster. One of the things which most of the time we get the question is how is it different from intra-cluster replication? The intra-cluster replication is different from the cross data center replication because the intra-cluster replication is within the cluster, right? So it's within the same system, whereas the cross data center replication is between the two different clusters, which are two entire different systems. We'll talk about the differences in detail. So let's start with the intra-cluster application, right? So in Couchbase Server, we can set up a intra-cluster application between the nodes. We support setting up a maximum of 3 replicas, right? So we can have active partitions and replica partitions on the same nodes. Here, the replication, the intra-cluster application, the way it works is all the active partitions, any changes to the data will be replicated to the replica partitions. In case if one of the server goes down, or if we take the server down for maintenance operations, we can activate the replica partitions to take the traffic. So in that case, this will be useful for availability within the cluster. If one of the server goes down, then we have the other server which takes the traffic. So this is different from the cross data center application, where the replication is going on between the two different clusters. Right, and these two replications, the intra-cluster and cross data center applications, are going parallelly. They are continuously going in parallel, right? So as you can see from the diagram, we have the intra-cluster application in both the data center 1 and data center 2. and we have the cross data center application, which is bidirectional XDCR between the data center 1 and data center 2. And you can see that the application server can do the read and write requests to both the data centers. So this is the main architecture of how the cross data center application works. So now let's look at the XDCR architecture. So this is a standard diagram which you might have seen in most of our Couchbase presentations. This is the single node of Couchbase Server, and if you might be aware about in Couchbase Server, all the nodes are identical. What that means is like every single node will have the same components, same processes, and they are all master nodes, right? Let's look at the single node of Couchbase Server, and let's see how the Couchbase write operation works with the XDCR, right? So here, the application server writes the document to the Couchbase server. First thing which happens is it gets written to the managed cache. So the managed cache is nothing but a built-in managed cache, which is nothing but a in-memory database, right? So with Couchbase Server, you get best of both worlds. You get both the in-memory as well as persistence, which is what uniquely separates out from the other database vendors. In most of the other database vendors, you would have the persistence layer, but you have to choose a solution for in-memory solution. But in our case, we kind of combine them together. We have this managed cache, which is basically in-memory database, which manages all the active data set in memory so that you get a very high performance, like some millisecond response time for any request, right? So the next thing which happens here is the document gets written to the two queues. The one is the replication queue, and the other one is a disk write queue. The reason we write to the replication queue, that's for the intra-cluster replication. That's for the durability, right? You want to make sure that you want to get this data out to the other server as quickly as possible. That's why we do it from RAM to RAM, so that the data gets sent out to the other server. In case if the server goes down, we have the data somewhere else, right? So that's the reason we write to the replication queue, which happens RAM to RAM. And then asynchronously, we write to the disk write queue, and which eventually gets persisted to the disk, right? And this is when the XDCR will take the changes which were persisted to the disk and pushes the changes to the other cluster, right? So the XDCR works only when the data is persisted to the disk. It's not when the data is in memory, but it's when data is persisted to the disk. And I'll give you the reason why we do this, because it's efficient to do this through disk, and we have a slide which explains about why we do this and what are the benefits we can see, right? So moving on, so just to reiterate the internal data flow. So first thing is document written to the managed cache. The second thing is document added to the intra-cluster application for high durability. Third one is the document added to the disk queue for persistence. And the fourth one is the XDCR does the push replication to the other cluster. One thing to mention here is the in cross data center replication in Couchbase is a push-based replication. So that means that any changes to the source cluster, it will push to the destination cluster. So now let's look at XDCR in action, right? So as I mentioned before, the main use cases for XDCR is the disaster recovery, the workload distribution, and also the data locality. In this case, let's take an example of data locality, right? So let's say that you're building an application and it's becoming very popular, right? And you had a data center in New York, and your applications were if your application were going to the New York data center. Now your application became very popular, and now you want to have a data center in the West Coast. So you build a West Coast data center. Now you want to keep both the data center in synchronization. You want to make sure that any changes which happens to the New York data center gets replicated. So in this case, what we do is we set up a replication streams between the two data centers, and this, as I mentioned before, these replications can be set up on a per bucket basis, which is on a per database basis, right? So now any changes which is happening, now we have a unidirectional replication which is going on from the cluster one, New York data center to the San Francisco data center. So the replication streams are set up. Any changes which are happening on the New York data center will get replicated to the San Francisco data center. In return, if we want to have the configuration where any changes which happens to the San Francisco data center needs to be replicated back to the New York data center, you can in reverse set up the unidirectional replication which goes from San Francisco data center to the New York data center. So in that case, we will have a bidirectional structure where both the data center will become active. Okay, so let's look at what are the different configurations we support in Couchbase XDCR. So here is an example of, like, we have two clusters, cluster 1 and cluster 2, and you see that we have multiple buckets on both the clusters. So bucket A is on both the clusters, but we don't have any replication going on between them. So users get to choose that whether they want to replicate the data or you don't want to replicate the data. So in this case, they choose to not replicate any data. Whereas for bucket B, we have a unidirectional replication to the bucket B on cluster 2. And the use case could be just for the disaster recovery or maybe hot spare or active backup kind of thing. But in the third case, which is for bucket C, we have a bidirectional application going on between cluster 1 and cluster 2, and this could be because you want to do the workload distribution, or you want to have the data locality kind of things, and this is why we support having different configuration for the across data center application on a cluster 1 and cluster 2. So now let's go a little deeper into, like, how actually this replication works, right? So this is more of like a continuous reliable application. What that means is once we set up this replication streams, by default we set up a 32 replication streams between the buckets. So as I mentioned, the replication is on a per bucket basis. But internally, we have shards for this bucket. We internally split this bucket into V bucket. We call them as a V bucket. These are the data partitions within the main bucket. So internally, this 32 replication streams will be round robin, and it will be serving all the data from V buckets to the V buckets from the cluster 1 to the cluster 2, right? And we can configure this replication stream. So I'll talk more about how to size your cluster when you are using the XDCR, because it's more CPU intensive, and if you want to span more replication stream, then you need to make sure that you have the CPU capacity there. So any changes which are happening on the source cluster gets replicated to the destination cluster, and as I mentioned, it's a push-based replication. And so another most common question user asks is, like, how do we if there is any network disruption, or if there is a failure on the source cluster or destination cluster, how do we make sure that you handle those cases, right? So what we have is something called checkpointing mechanism. So we checkpoint every replication going on a V bucket level. So on a per V bucket or a per data partition level, we checkpoint and see what data has been replicated already and what data has not been replicated. So in case if there is a network disruption, and when if there is a replication fails, and once the replication is re-established, we know exactly where the replication was stopped, and we can continue from there. So we need not start the replication from the beginning. So another important thing here in Couchbase and the XDCR in Couchbase Server is it's a cluster topology aware. What that means is if you have any changes in the topology, you can add more servers, you can remove some servers from either cluster, or you can have arbitrary number of servers on both the clusters. It's topology aware. So the way it works here in Couchbase is because XDCR has the same information, same vbucket map, which is partition map. It knows exactly where the data is which data is on which node, and which node has what buckets, right? So it has all this cluster map information. So because it knows exactly what partitions are on what node, if there is any change to the topology, if we add a new node and if some of the partitions get moved to the new node, so the XDCR will know that there's a topology change, some partition has moved to the new server, and it will automatically take care of establishing the replication stream to the new partitions and start replicating the data to there. So it happens everything behind the scene, everything is taken care. So when I do the demonstrations in the demo, I will show that when I add a new server to the cluster, the existing replication will keep continuing without any disturbance. So I did discuss about the efficiency in replicating the data from the disk and not from the memory. In case of intra-cluster, we do it from the memory because we want to make sure it's we want to get the data as soon as possible out of the server, so that in case the server goes down, we have a backup somewhere else. But in case of XDCR, the changes to the replication happens from the disk. When the data is persisted to the disk, that's when it gets pushed to the other cluster. The reason we do that is it's much more efficient to do that. We have a feature which is called deduplicate, right? What that means is, let's say you are building you have a gaming application and your player is making a lot of points, right? So there's a lot of changes which is happening for that player, and within a span of time there might be thousands of changes coming to that particular document. Now, if you keep pushing all these 1,000 changes to the other cluster, there'll be network usage, right? So the way we avoid this is what we call it as only last version of the change gets written to the disk. So we basically do deduplicates and only write in the time of whatever time of seconds or in minutes, whatever changes happen to the particular document, only the last version gets written to the disk, and only that particular change will get sent out to the other cluster. So we internally manage something called revision ID, which keeps track of all the changes which are happening to the document. And if we have a bidirectional replication, and I'll discuss this a little bit more in detail, in that case, we check the revision ID, we check which document was updated most recently, and only that document get sent or pushed to the other cluster. So yeah, on the conflict resolution, right? So we discussed about having a bidirectional application. The most common question is again, conflict resolution. How do we handle it, right? The Couchbase server within a cluster is very strongly consistent, because all the read-write operation happens from one application server and only one Couchbase server, and we send that changes to that from that Couchbase server to the other nodes in the cluster for the durability. So basically, within the cluster, the data is strongly consistent. But in case of XDCR, since the data has to persist to the disk first and then gets pushed to the other cluster, it's eventually consistent. So if a document is changed, and now in the case of bidirectional replication, if we have an active configuration where both the clusters are active and both clusters are taking read and write operations, so in this case there is chances of write collision, or there is chances of a conflict, right? If maybe the same key might get updated on both the clusters. So the way we handle this is using the first thing we do is using the mechanism called which document got which key got updated a lot. In the sense where there were a lot of changes to that particular document. The figure here shows that the document 1 on a data center 1 got updated only once, whereas the document 1 on the data center 2 got updated 3 times. So now we pick the document which was updated 3 times as a winner. But in this case, this might not be the good solution, where the document 1 or the DC1 can maybe was updated at the same time as the document 1 on DC2 at the 3rd time. So to avoid this, what we have other metadata information. We have internally maintained something called sequence number. We have cache value, revision ID, and the cache value is nothing but the Unix timestamp. we have other metadata information to do the conflict resolution and pick the winner between the clusters. So to just give you an idea on how this works like end to end is like when any changes happens to a document in cluster 1, we do a get meta operation. We don't actually send the data blindly. We always make a get meta operation first. In the get meta operation, it will go and check the destination cluster to make sure whether the destination cluster has this document. If it doesn't have, then it just pushes the document to the other cluster. If the destination cluster has the same document, same key, but it has the older revision ID, even in that case, the document gets pushed to the other destination cluster. If the destination cluster has the same key, but it has more updates than the source cluster, then it will reverse. In case of bidirectional, that changes will be sent back to the source cluster. So that's how it works end to end. So for every replication, we do a get meta operation to verify and then send out the changes. So before moving on, okay, so let's move on to the next part, which is configuration and monitoring. So here we will discuss about how to configure the cross data center replication, right? So the way we do that is like we can create a cluster reference. The reason we set up a cluster reference is if you, as I mentioned before, you can create the replication between for a database like on a per bucket basis. So let's say that once you create a cluster reference, you can basically use the same reference for setting up the replication for different buckets. And also, when you create a reference, all you need to do is provide a cluster name. It's just to identify which cluster you want to call it. And the second thing is you have to provide IP address or IP address of one single node on the destination cluster. And that's all you need for setting up the cluster reference. Here, when we provide the IP address of one node on a destination cluster, it basically what happens internally is the source cluster will try to connect, try to make a connection to the destination cluster. It will check if it's able to talk to all the servers, all the nodes in the destination cluster. So once it verifies and it gets the cluster map information, it gets the information about what topology it has, like how many partitions, how many nodes the destination cluster has, and what partitions are on the what nodes. So it basically gets the cluster map information. So once it does, once we verify the security, the username and password, it basically creates the reference. So once we have the reference set up, the next thing we do is creating the actual replication streams. So here, what happens is as I mentioned before, you can basically tell which bucket you want to replicate and which bucket you don't want to replicate. So here in this example, from the source cluster, I'm picking the bucket which is default, and I want to replicate only the default bucket to the other cluster. So, but let's say that you have multiple buckets on the source cluster, and you want to replicate all the buckets to the destination cluster. In that case, you have to repeat this step 3 times. In that case, you have to do the same thing for all the buckets. There's right now no easy way to like set up for all the buckets at a one shot. You have to do it multiple times. So once you set up the replication, here by default 32 replication streams are created from the source cluster to the destination cluster on a per bucket basis. So again, you might be wondering, once we set up the replication, how do we see the status of the replication? What are the what we can see on how do you monitor the replication? What are the things that are happening? So we do provide a bunch of stats. As you might know, with Couchbase Server, we collect almost 200 plus stats from the cluster. In the recent releases, we have added much more stats to the XDCR, and I'll talk in detail about what this stat means on the source cluster and on the destination cluster. So now let's talk more about what topologies we have, or what topologies we support, and what are the use cases. The most common topologies we have is, again, unidirectional application and bidirectional application. And in unidirectional application, it's one way. It's one way, which is from the source cluster to the destination cluster. And the reason you might, the number of use cases you might think of is you might want to have a hot spare or an active backup in case of disaster recovery. I have seen the use cases where, like, if you want to do a hardware refresh of the entire data center on the source cluster, in that case, you might have this unidirectional application going on, and when you want to do the hardware refresh, your application servers might go to the destination cluster for any read-write operation, right? Another unique use cases we have seen is, like, if you want to have provide the production data to your developers or development team or test team for doing a development on the production data or test against your production data. So we can set up a unidirectional application, and this won't affect anything. This won't affect your production. It won't affect anything. So whereas before, the administrator would have to take a backup of the data and send it over, this is much convenient and much easier, where you can just set up a unidirectional application, and you can get a subset of the data, and then you can even kill the replication after that. So with that, you can now, your development team and your test team can work on the production data for their development as testing. So the bidirectional application is both ways. You have the replication going on between the source and destination cluster in either direction, and there are a lot of use cases where we have this active-active kind of configuration, where both the clusters will take, the application servers will be able to do the read and write operation on the both clusters. We might think of why we would do this is, like, if you have, if you are already hitting a capacity in one of the data center, then you can bring up another data center and have the bidirectional application, so you can distribute the workload, right? The other main use case is for the disaster recovery. In case if your entire data center goes down, then you have the other data center which can, like, serve the request for the application. And also, the other major use case is for the data center locality, which is bringing data closer to your user. Let's say that as I mentioned before, if your application becomes viral, if you becomes very popular, and now you want to have a sub-millisecond fast response time. In that case, having a data center which is closer to your user will make sense. So, for example, to give you an example, in a ad targeting kind of application, right? So if you have a requirement of a sub-millisecond response time for making some business decisions, in that case, if you have a data center very closer to the users, wherever in the East Coast or West Coast, or it could be on a different continent, then it will be much faster to access the data compared to whereas if you have a data center in North America, and if your user is in some other continent, then there will be multiple hops he has to go through to get the data. So because we have this unidirectional and bidirectional application, utilizing those configuration, you can create much more complex like structures. We can have a chain replication where you have the unidirectional application between between the data center 1, 2, and 3, where the data is getting pushed to one level down and it gets pushed to another level. So this structure is getting common, where depending upon your application requirements, you can utilize this structure. So here it's like the data center 3 will have the changes only after the data center 2 sees the changes. Another common use case we have seen is the data aggregation. So what we have here is within the North America, right? We have a data center 1, which is which is having a bidirectional application with the data center 2, and there is data center 3 and 4, which has a unidirectional application going on to the data center 2. This is a typical use case where we might have a regional office and on the up north, and 2 regional office, and you might have the local offices somewhere in the south where there are the changes to that data will be getting pushed to the regional offices in the north. So if you so most of the around 30 to 40% of our Couchbase deployments are on EC2. So if you are choosing to go do the deployment on cloud deployment on Amazon EC2, so if you are planning to set up a XDCR, so what are the things which you need to consider? So some of the things which you need to consider when you are setting up the XDCR on the cloud is you need to have a DNS name. So it needs to resolve to internal IP address for intra-cluster communication, and also a public address for the cross data center application. So there are documents on our documentation page, and also if you go to Amazon, it talks about how to set up the DNS CNAME for the public IP address for the setting up the cross data center application. And also another important thing to see here is XDCR on the cloud. The traffic on the XDCR is not encrypted. What that means is any data which is going on the XDCR is not encrypted. It's so if you have a cloud deployment, in most cases it will be on the public internet. So data is not encrypted. You need to make sure that you need to encrypt the data. So the way you could do is have a VPN gateway between the data center 1 and data center 2, which encrypts the data. And there are other solutions, like you can consider the third party, the Amazon VPN solution for encrypting the data, making sure that nobody nobody can read your data. So that there are multiple solutions for that. So, but currently in Couchbase we don't have the encryption of the data on the XDCR. So another thing which we when we get a question about, like, when we set up the XDCR, what are the things we need to consider in terms of sizing, right? How is it going to affect the our Couchbase cluster? So XDCR is definitely a CPU intensive. It's going to be CPU intensive. So if you are creating a XDCR cross data center application between the data center 1 and data center 2, you need to size your data center. You need to size your capacity for your data center, because when we set up a replication, it basically creates multiple streams, and that's going to add more CPU capacity. So we do provide a bunch of configuration settings where you can increase the streams or decrease the streams depending upon your CPU capacity. But what we recommend is, like, if you are trying to have a XDCR, you need to size it properly based on your CPU capacity. So with the XDCR, it's also going to add more memory capacity. It's going to be memory intensive also, because it's basically doubling the data on the in case if you have a bidirectional application going on, it's going to definitely utilize more memory. So it's recommended to size your memory accordingly. So now let's switch to the demonstration. I will demo how to set up the XDCR between the clusters. So what I've done is here is a right scale template. So if you are not aware, we do as part of cloud deployment for Couchbase, we have right scale templates which you can use for spanning up the creating an instance of the Couchbase server on EC2. I have created a bunch of instances and set up a cluster 1 and cluster 2. Let me show you how many servers I have in the cluster 1. So we have 4 servers in cluster 1, and we have again 4 servers in the cluster 2, right? And if you look at the bucket, which is basically as I mentioned, it's identical to database. The number of buckets in your cluster. Right now I have only 1 bucket. If you click on the bucket, it will show you what's happening with this bucket. Right now, on the destination cluster, you'll see that there's nothing happening on the bucket. There's no sets per second or no operations per second. On the source cluster, I'm running a simulator, like node simulator, I think so it's pumping some data. So let's look at the default bucket on the source cluster. You see that there's a bunch of operations happening. So there are some 6K or 5K operations per second. Around 5K gets per second, 88 sets per second. So there's some activity happening on the source cluster, right? So now you decide to have a replication between the cluster 1 and cluster 2. So as I talked before, the way you could do is using the XDCR tab on our admin UI console. So if you go to the XDCR tab, if you are trying to set up a replication from one cluster, it will always show you the replication which is set up on that cluster. So if we have a bidirectional replication, so it will show the replication on both the clusters. So let me demo that. So as I mentioned before, so if you want to set up the replication, you need to create the cluster reference. Let's call this as West Coast. IP address of one machine on the destination cluster, which is username and password, and hit save. So what it did is it just created a reference. So basically it made a connection to the destination cluster. It made sure that it found out how many nodes are in that destination cluster, what buckets are created on the destination cluster, which partitions are on which nodes. So we basically got a cluster map information. So once this reference is set up, now you can set up actual replication. So now when you hit create replication, you'll get this screen where it will ask you which bucket you want to replicate. So in my case, I have only one bucket, so I'll say default bucket. So before you, let's say I'll pick up the West Coast cluster. Before you actually give the bucket name, you have to make sure that if you go to the destination cluster, we have the default bucket. You can choose to give a different name, but let's for the demo, I will give the same name, default, and hit replicate. So when you hit replicate, and now as you can see the status, it says replicating. What that means is now the replication has begun. So the data has started moving from the source cluster to the destination cluster. Now you will be curious to know how it's happening and what changes, how much data is getting pushed. So the way you can check is that when you click on the default bucket, if you scroll down, so you can see the two stats here. One is the incoming XDCR and outgoing XDCR. Since we have a unidirectional replication, it's only the outbound XDCR. So you can see that there are 4 outbound XDCR, which is the number of mutations to be replicated. That's the number of changes which needs to be replicated from this cluster to the another cluster. If you quickly switch, so we have a few other tabs. If you go look at, so we have a bunch of stats on the number of mutations to be replicated. If you click on the particular stat, it will show you how many operations are happening, like how many mutations are getting pushed to the other cluster. We do have a bunch of other stats, like if this is the mutation check, these are the number of changes which are persisted to the disk and ready to be pushed to the other cluster. These are the number of mutations which are already replicated, and this stat gives you the amount of data which got replicated. So likewise, we have a bunch of other stats, and we do have some the text which explains what the stat means. If we switch to the destination cluster, we can see that there's a lot of activities happening now since the data is coming from the source cluster. So you can see there's 115 ops per second, and again we have the same same XDCR stats here on the destination. These are quite few which talk about how many metadata reads per second are happening, how many sets per second are happening, and what's the total ops per second. So this gives you an idea like how to, like when you set up the replication, how to monitor your replication. And also we have this aggregation. This is on a minute base. We can change it to the hour. We can change it to the day, week, month, and year. Since I was not running any load before, so it just shows you for the that a few minutes back. So you can see that the replication started like 2 minutes back. So now we talked about how to set up the unidirectional replication. Now let's see how the bidirectional replication can be set up. Now in this case, if I want to set up a, we can do the same steps. We can go create the cluster reference, East Coast, IP address of one of the machine from the source cluster, destination cluster. So I pick the IP address, and username and password. Hit save, and it creates the cluster reference. So once the cluster reference is created, now we can create the replication. Right? So from this cluster, which is again the West Coast cluster, we can replicate the set up the replication to the East Coast cluster, and the bucket name set it to default to demonstrate that it goes to the same bucket. If you give some other bucket name, it will create the new bucket on the destination cluster, and so we will have even though it will be a unidirectional replication, it will not be bidirectional, because in that case it will be writing to another bucket. So in this case, if it's the same bucket, we will have a bidirectional replication going on. Now if you go back to the bucket, and if you see the default here, you will see that there's a outbound XDCR. Any changes which are happening on this cluster will now get replicated to the other cluster. So now we have active replication going on between the source and destination cluster. And I also promised you that I'll show you if there's a topology change, how do we manage it, in the sense like what happens. So I have set up a new another Couchbase server. It's a standalone machine. There's no other machine. It's just one machine. So if I add this machine to our existing cluster, so if I take this machine, and let's go to the cluster, East Coast cluster, go to server nodes, add server, and give this IP address, right, and username and password. So now we add the server. It will give you a warning saying that any data which were in that machine will be now deleted. So you have to make sure that if you want to back up your data, you can back up before you add the server. So when you hit add server, this new server is in a pending state. It's not yet part of the cluster. This is really one useful thing, because if you are planning to increase your capacity by adding more servers, you can add them all together and then hit the rebalance once, so that you don't have to move the data again and again, right? So now, as you saw that the XDCR, we have bidirectional application going on. We had only 4 servers before. Now when we do the rebalance, that is like we add a new server, now you see that some of the data partitions from the old servers are getting moved to the new server. So this new server is still in the pending state, and it got changed to the active state, which means that some partition already got moved to the new server, and they started taking the traffic. So you can also see the progress here, and if you click on this server, you will see that some activity started happening here. And if you want to see exactly how many V buckets got moved, we can go to this stat, click on show by server. You can see that this is a new server which we got added. And you can see that the other 4 servers, some of the data partitions are getting decreased, because they are getting moved to the new server. So it's basically distributing the partitions to the new server. So while this whole operation is going on, the whole rebalance operation is happening, how it is affecting the on destination. So I can see that there's nothing getting affected on the destination. The replication streams automatically got updated. They now know that the new node got updated. There's a topology change, and now the replication has to take care of these changes. So it automatically re-establishes the replication stream to that new node. And so the whole operation is like behind the scenes. Everything is taken care, so you don't have to worry about anything. So this is how the whole XDCR cross data center replication works in Couchbase. Switching back to our slides, so
this is Baxter. Just wanted to mention, if you have any questions, feel free to please ask them via the GoToWebinar panel. We will start addressing the questions in 1 minute, so go ahead and type them in now. In the meantime, while giving folks a chance to type in any questions they may have, wanted to mention that our annual user conference is coming up on September 13th. It's in San Francisco, Couchbase San Francisco, and we have featured presentations from a number of great speakers, including PayPal, Orbitz, LivePerson, McGraw-Hill, Nielsen, HP, and others. And we're still doing reduced rates for registration. So if you haven't had a chance to check it out yet, please do so. You can head to the link at the bottom of the slide here, and you can see all the details around the agenda, and you can register and so forth. So really encourage you all to attend. Last year was a great event, and we're really excited about what we have going on for this year as well. At this time, let's go ahead and look at some of the questions that folks have asked. First question is from Jan. We plan on moving one bucket from a shared to a dedicated cluster. Would you recommend XDCR for that, or is there possibly another way that's better that we should consider?
So in your case, if you are moving the bucket from one server to the other server, if it's a one-time thing, you can use we have a bunch of database tools we provide as part of our Couchbase Server, which is a backup and restore tool. You can use that feature tools for backing up your data and restoring it on the destination cluster. But if you have a requirement that while this whole thing is happening, if you want to make sure that the application server doesn't get affected, in the sense that if you don't want to see any disturbance there, in that case, yes, you can set up the unidirectional replication, make sure that the data gets pushed to the destination cluster, and then when you're ready to make it live, you can switch off the old server and switch on the new server.
Great, thank you. A question from Alon: Does it matter which server, in terms of when you're listing the servers with the IP addresses, on the destination side that you select, or can you select any server?
Yeah, I figured you would ask, someone from the user will ask this question. So you can pick any server in the destination cluster. It need not be a specific one. When you pick one server from the destination cluster, that would be chosen as a orchestrator. Basically, that will be chosen one for figuring out all the other nodes in the cluster. So it basically acts as an orchestrator. It gives the cluster map information to the source cluster. So that's how we establish the connection to the destination cluster. Great.
We have a question from Babu about what happens if a node goes down. So will XDCR continue in the case of a node failing?
Yes. So as I demoed in the demonstration, this was where we added new server, right? So your question is like, when if the server goes down, it behaves exactly the same way. So even if the server goes down, the partition map, the cluster map gets updated, the topology changes will be updated. So even if the replication streams were still going to the old server, they will start getting the errors. We will see these errors, and the source cluster will come to know. Even if the server failed on destination cluster or source cluster, the cluster or the other cluster will come to know that there is some the topology change has happened. So that will happen. The process is like this. So let's say that one of the node goes down, and you do a failover. So when you do the failover operation, it knows that the cluster knows that the server is marked as down. It's blacklisted. It's no more reachable. So now the cluster map will get updated, and the other cluster will know that topology change has happened, and now it needs to re-establish the replication streams to the new or to the new node for that partition.
Okay. We have a question from Brian about: is there a max data size that can be replicated across clusters?
So we do have. So currently we have we can set the batch size of how much data you want to push the data from one cluster to another cluster. This all can be configured. If you refer to our documentation, you can see the specific commands, the CLI commands you can run for changing these settings. As far as I know, there's no max size of data you can push. So yeah, so you can check our documentation.
Okay, great. You talked a little bit earlier about sizing, and you also talked about the increase in memory required. So how much extra memory overhead is required, or is there any sort of best practices or guidelines that we could provide?
Yes, so definitely Yes, we do recommend a lot of users to go through the sizing. There's a blog on the in our Couchbase written by Perry, who is our solution architect. He talks about how to size your cluster when in case of XDCR, when you're setting a unidirectional replication or a bidirectional application, how much CPU extra you need or how much memory you would need. So it talks more in detail about how to size your size your cluster.
Okay, great, thanks. Any general guidelines on how long it typically takes to replicate a data set across clusters?
So what we have seen is like again typical. If you are doing a replication from the Amazon on the Amazon cloud from east region to the west region, we have seen roughly below the 10 seconds time frame. But again, it depends upon how much data you're replicating and what configuration you have.
Okay, great. Here's a question from Brian, and he says, it seems to make sense to keep all of your bidirectional data in one replicated bucket with mixed documents instead of moving many buckets with different documents. Is this more efficient?
So that's a very good question. So the reason we kind of have it, when I talk about having replication on a per bucket basis. So when when you create a replication on a per bucket, it creates by default 32 replication streams. And if you have more control on a per bucket basis, so if you, let's say that you want to add more streams, so if you have more CPU capacity and you want to add more streams, and because internally within a bucket we have this vBucket concept, which is a sharding of the data partition. And this replication streams will be round robining within and serving all the serving on all the streams. So if you have more, you can increase more streams, and that way you'll get a more replication rate. You can push more data to the other cluster. So whereas if you have multiple buckets, you can basically create multiple streams. But if you have one single server, one single bucket, and if you want to do bidirectional replication, then it will be like creating the replication stream only on that particular bucket.
Okay, great. What happens, and you may have addressed this earlier in the question about a node failing, but what happens when the XDCR reference server fails? Can you have multiple routes?
Yeah, it's a good question. So when we set up a XDCR for one particular, when we pick one node on the destination cluster, if that particular node goes down, then there will be like a election of a new orchestrator, like the new node on the destination cluster. But the XDCR won't see any effect; it will keep continuing.
Okay. We had a couple of questions in a similar vein about the policy for which document wins in the matter of conflict resolution. So is there any way to change that policy or define it other than the document with the most update winning in those cases? So
again, a very good question. Currently, we don't have the option to change the policy. This is all taken care automatically. But in future releases, we have something on the roadmap where we will let the user pick the policy. Like we let the user choose which document wins, and in the sense like we give decision for user to we'll let the user make the decision. So that's on the roadmap, and we don't have that currently.
Okay, great. Question about strategies for multi-phase commit. So if there's a write that's particularly sensitive and would like some assurance or acknowledgement, the confirmation that the write is committed in both those data centers.
So right now we do support that feature using a API called Observe, which makes sure that if you want to make sure that your write happens on the one server as well as within the same cluster on the other server. So basically the API will write to the managed cache, wait till that data gets replicated to the another server, and only then when it is on the other server and got persisted to the disk, it sends back OK to the acknowledges to the client. So, but that feature is not currently available on the XDCR, which is one of the things which we are looking for in the upcoming release, to add that feature of making sure that write happens on the destination cluster and destination data center, and then acknowledges back to the client.
Okay, great. We have time for one more question before we wrap up here. So what happens under high load when the queue for replication becomes full? Will it slow down the response time?
So it won't affect the source cluster. The replication queue is building up, so it needs to push a lot of stuff to the destination cluster. But the only effect, the bad part here is the destination cluster won't see the data. And if there is an application requirement that if they are looking at this, looking for some changes, that won't be up there because there's a huge replication queue and data is still in the source cluster and it's not replicated yet.
Thanks, Anil. Thank you, everyone, for your questions. If we didn't have a chance to address your specific question, we'll follow up with you after the webinar. Just give us a little bit of time to reach out, and would gladly address any questions you may have. If you haven't had a chance to download Couchbase and try it out at this point, we encourage you to head to our download page and select your preferred platform and download it and try it out today. After the session, we'll send out a link to the slides and the recording of the webinar. And if you could just take a second to please fill out the survey that will open when you close out of the session today, we greatly appreciate it. And just want to say thanks again for joining today, and look forward to seeing you hopefully at Couchbase SF or a future webinar. Have a great day, everyone.